Okay, just reviewing, we've reduced A to LU form. We know what L is, there it is. We know what U is, there it is. Our equation AX equals B is LUX equals B, which is solved by multiplying both sides by the inverse of LU, and the inverse of LU is U inverse L inverse. So X is U inverse L inverse B. L inverse B is the solution to the equation Ly equals B. Because of course if you multiply both sides of this by L inverse, you get Y equals L inverse B. But we solve it this way because this form, since L is lower triangular, gives us a system that we can solve easily by forward substitution. We get the solution, and now we can replace L inverse B with Y equals a column vector, -1/5, 42/5. So, again, X equals U inverse L inverse B. L inverse B is a solution to this, and that's this. So, X equals U inverse Y, where this is Y. Now, it follows that UX equals Y, multiply both sides of this by U, you get U inverse here, which is the identity, so you just end up with Y, and you end up with UX here, and that's very straightforward. Okay? So, what's this system? We can solve this system for X. X, we'll just call the column vector X1, X2. Here's our upper triangular matrix, the upper triangular matrix that we found previously, and that's going to have to be equal to the Y vector that we found by doing the forward substitution on the lower triangular matrix with our original B vector. So here we have the equation, and here we have it written as a system, and it's very easy to solve. We use backward substitution because we solved the second equation for X2, and if I did my arithmetic right, and the arithmetic is actually pretty simple, X2 is 42/19. Okay, that's very straightforward. We plug that into the first equation, so we replace X2 with 42/19, so it's X1 minus 2/5 of 42/19 equals -1/5. Now that's just fifth grade arithmetic. We solve this very easily, and I've written out the details, but I'm not going to go over the details of the fractions. If you don't know them, learn what you knew when you were in fifth grade. Okay? And we end up with X1 equals 191/95, and we can attempt a prime factorization. It turns out that 191 is prime. It's not divisible by 3 because 3 goes into 180, leaving 11, and 3 doesn't divide 11. It's obviously not divisible by 5, it doesn't end in 0 or 5. It's not divisible by 7. 7 goes into 140 20 times, leaving 51, and 7 doesn't go into 51. Not 11. 11 goes into 220, and this is 29 less than 220. 11 doesn't go into 229. 13, well, 13 goes into 169, but it doesn't go into the remainder there, which would be 22. So that's not going to work. And 17 goes into 189, and so it's clearly not going to go into 191. And wait, that's totally wrong. 17 goes into 289, and 13 goes into 269. So, you know, I was actually, am I right? Yeah, 12. No, 13 goes into 169. 17 squared is 289. Okay, late in the afternoon. So, you know, everything I said is right, except I didn't need to divide by 17 because what you get when you divide 191 by 17 is less than 17, since 17 squared is 289. And if that had divided it, we would have found it by dividing by the smaller primes. Anyhow, this is something, yeah, look up least common multiple, greatest common divisor, how you get that using prime factorizations. And make sure you understand prime factorization because it underlies a lot of operations that you do in more advanced courses. And it's also important for numbers. So anyhow, without that little digression for the fractions, I said I wasn't going to do that. Of course, prime factorization 191 probably isn't fifth grade arithmetic. Could be. You see that what we've done is we've attained the LU decomposition. We found the solution to y equals L inverse B, there it is, so that we can replace L inverse B by this y and get U inverse y, which is equivalent, so this equation being equivalent to Ux equals y gives us this matrix equation corresponding to this system, which is easily solved by backward substitution. Solve for x2, plug that solution in here, and solve for x1. So our ultimate solution is x equals negative 1/5, 42/5, and you can check to see whether that solves the equation. Our A matrix is 5, negative 2, 7, 1 times x equals the B matrix column, which is negative 1, 7. Okay. If we plug this in for x and do the matrix multiplication, this should work out. Now, if I made a silly arithmetic mistake, maybe it won't, and maybe you want to go back and correct that. But then I gave you a worksheet that asks you to do exactly the same thing for a different matrix and a different column vector, just so you practice the process and think about what every step means. Now, I don't think you're going to have any trouble with that, but you do want to be sure you understand all the details and nuances as best you possibly can.